this video, we will see a problem on shear force and bending moment for the beam given. Here is the question that draw SFD and BMD for the beam given. This is the diagram provided to us. Now, if we see here, this beam is simply supported at A and D. Then at B, there is a couple acting whose value is 60 kN meter, located at 3 meter distance from A. Next, at C, there is a couple 80 kN meter, located at 3 meter distance from D. Now, for such a beam, we have to draw SFD and BMD. The first step would be calculation of support reactions. Solution. Step number 1. Calculation of support reactions. Here, I use the first condition of equilibrium. Summation of Fy is equal to 0, where upward forces are positive and downward forces are negative. Here, there is no need of summation effects because no horizontal forces are there. So, therefore, if we see here, it is supported at A, so there will be reaction at A. Supported at B, so reaction at B. Both are upward, so positive. Ra plus Rd. Now, if we see here, there are no vertical forces over the beam. Only couple is there, no forces, no UDL, no point load, no UBL. So I'll say that the total amount of loading here is equal to 0. No vertical forces. So therefore, Ra will be equal to minus of Rd. This will be equation number 1. Then summation of moment about A is equal to 0, where clockwise moments are positive and anti-clockwise moments are negative. So if I take the moment at A, Rd is producing, it is acting upward, it will produce anti-clockwise moment at A, so minus Rd into the distance is 10 meter total distance from D to A. At the same time, here in this problem, we have two couples, both are acting clockwise, so will be treated positive. So plus 60 plus 80 is equal to 0. So therefore, on calculating, I'll get the value of reaction at D as it will be 14 kilonewton. Therefore, put Rd is equal to 14 kilonewton in equation 1. So we have Ra is minus Rd, so that will be minus 14 kilonewton. So here we complete step 1, that is we have calculated the support reactions. Next, step number 2. Shear force, that is SF. Calculations. For that we need to have sign convention, because without sign convention we cannot move ahead in this problem. Now here, to the left of the section, upward force is treated and downward force, both are treated as positive. Then downward force to the left of section, upward force to the right of section, both are negative. So with the help of these conventions, we'll find the shear forces. Now, if I look at this beam, then when the section is to the left of A, on the left of A there are no forces, so the value of shear force will be 0. But if I take the section to the right of A, RA value is there. It is minus 14. Minus 14 kilonewton. Now, so to the left of this section, there is a force which is acting upward, so it will be positive, and I'll write the value as it is, that is minus 14. Because the value is negative here, I'll write it as it is. So therefore, SF at point A is equal to minus 14 kilonewton. Then, now if we see here, something interesting is there in this beam, that there is no load from A to B. It means SF at point B will also be same as A, minus 14. Next, SF at point C, there is no load between B to C, so again SF will remain constant, that is minus 14 kilonewton. Then again there is no shear force between C to D, so SF at point D will also be same, minus 14 kilonewton. The values are same. So now, after getting the shear forces at each of the points, we need to draw the shear force diagram. For that, I'll draw the beam again. Here I'm projecting the points downwards. Now, this is the given beam, and here we have found out the reaction also. At A it is minus 14 kilonewton, at D it is plus 14 kilonewton. Now, below this, we need to draw the shear force diagram. Here I am drawing a horizontal line which has 0 kilonewton shear force. Then the values of shear forces at each of the locations, they are same here, that is minus 14 kilonewton. So from 0 to minus 14 I plotted downwards, and this minus 14 kilonewton will continue from A to B up to C and finally up to D. It means shear force is a rectangle here, minus so this is the shear force diagram for the given problem. So now, after completing the shear force diagram, I can say that step number 2 has been completed. Now step number 3, that is bending moment calculations. Bending moment calculations. For this also, like in case of shear force, we need to have sign convention first, without which we cannot solve the problem. So to the left of section, clockwise moment, to the right, anti-clockwise moment. Both are treated as positive. Then to the left of the section, anti-clockwise moment, to the right, clockwise moment. Both are treated as negative. This positive bending moment, it is also called as sagging bending moment, and negative, it is called as hogging bending moment. Now, here, as we see here, it is a simply supported beam. So the bending moment at A and D will be zero because they are simply supported. So first, moment at A is equal to moment at B, and that is equal to zero since it is simply supported. Next, here we have point B at which a couple is acting. So whenever we have a point over which the couple is acting, at that point we will get two values of bending moment. First, by taking the section to the left of the point and then to the right. So first, when I'm taking the section to the left, there won't be this couple acting but only the force. So moment at B will be equal to, now this moment produced by B, that is in clockwise direction. So moment produced at B, that is because of RA, it is in clockwise direction. So to the left clockwise is positive. So here we have RA into 3. Then there are no other forces here. So RA is minus 14 into 3. So moment at B comes out to be minus 42 kilonewton meter. Next, another value at B, because there is couple acting. So moment at B is equal to, now this minus 42 will remain same, but here again if I am taking the section to the right, then to the right of B, then to the left of this section there is even 60 kilonewton. It is clockwise. So to the left clockwise is positive. So in this plus 60. So this comes out to be plus 18 kilonewton meter. Next, similarly I'll calculate the moment at C. So for moment at C, if we see here, at C also there is a couple acting, so there will be two values of bending moment. First, when I take the section to the left, there will be RA into 7 and it is producing clockwise moment, so positive to the left. RA into 7, which is equal to RA is minus 14 into 7. So therefore moment at C comes out to be it is 38 kilonewton meter. It is 38. When I calculate this, here we have minus 14 into 7. At the same time, there is one more thing here. When I'm calculating the moment at C, I have to even consider this moment also. So this is plus 60 because to the left of C, this is clockwise couple. So in this, I will have to add RA into 7 plus 60 for the clockwise couple. So RA into 7 in that plus 60. So now this gives me the value as 38 kilonewton meter, which is positive. Next, apart from this, we have another value at C. So moment at C will be equal to, this value which I am getting, actually this is not plus, this is negative minus 38. This is a negative value. So moment at C will be minus 38. Now in that I will be taking the section. First I put the section to the left of C. Now to the right of C. And when I am taking the section to the right, to the left I have clockwise 80 kilonewton meter. So that is positive. So in this plus 80. So therefore the moment at C will be, now this will be plus 42 kilometer meter. So these are the values of bending moment which I am getting. Then at A and D they are 0, so we need to draw the bending moment diagram. Bending moment diagram will be drawn below the shear force diagram. This is 0 line, 0 kilometer meter. At B there are two values. First minus 42 and then plus 18. So minus 42 is below the line, plus 18 is above the line. Then at C there are two values. First minus 38, then plus 42. So minus 38 will be in the negative region, then plus 42, which is positive. So how I would be joining this? Since there is no road between A to B, bending moment will be an inclined line from 0 to, it was minus 42, 0 to minus 42. So these will be joined, these 2 points. Then minus 42 to plus 18. After that, to plus 18 it is minus 38. And from minus 38 it is up to 42 kilometer meter. And finally from 42 at D the value is 0. So again there will be inclined line joining because there is no load between C to D. So here we see that whenever there is no load between 2 points, that is A to B, B to C, C to D, bending moment will be inclined line. Plus these are minus values. Now in this problem, as we see here, there is a point where bending moment crosses from positive to negative, and at this location the bending moment becomes 0. So here the bending moment value is equal to 0, and this point will be called as point of contraflexure. And here what I'll do in this problem, I'll also locate this distance, that is find at how much distance, I'll call it as x, we are getting the bending moment as 0. So now here in this problem I'll add that also find the point of contraflexure. Now point of contraflexure is that point at which the bending moment is 0. So for that here I draw the two triangles. Now, to find the point of contraflexure, which is this point, that is here the bending moment is 0, I'll take the distance x, means I'll find the point of contraflexure with respect to point B. So the remaining distance will be, total is 4. So from 4 I am subtracting x, that is 4 minus x, which I have shown it here. So therefore, by similarity of triangles, since we have 18, that is this triangle, the height of this divided by the base, which is x, is equal to 38 divided by the base, which is 4 minus x. So height will be there in front of height, base in front of base. So therefore 18 into this will be cross multiplied, 4 minus x is equal to 38x. So therefore this will be 72 minus 18x is equal to 38x. So therefore 18, I send it on to the other side, it becomes positive. So 38 plus 18, that is 56x. So 72 divided by 56, x value will be 1.285 meter. This will be with respect to point B. So here I have located the point of contraflexure from point B, that is it will be at a distance of 1.285 meter from B, where the bending moment is 0. And with this we complete the